Good evening. Now today we are going to be with NPTEL assignment. Already we have solved 4 problems. Now we will go with 5th problems. Now it was asked that choose the correct influence line diagram. Now reaction at B. Now if we will draw ILD for reaction at B, then you are going to be in this fashion. I will draw this is A. Then we have D 4 meter. Then we have C over here. And then we have B over here. So ILD for reaction B we have in this fashion. So now this is not correct because this is D is given, so this is wrong. Now ILD for reaction at A. If you will plot ILD for reaction at A, then you have 1 at A, we have 0 at D, and then we have 0 at B. And therefore, if you will plot this, then you will get diagram will be in this fashion. This is for RA, this is for RB. Now this will be wrong. Now ILD for bending moment at D. So now last we have seen for ILD for bending moment at D. So we will say RB into D. So till D, unit load is between A to D, my value of RB is 0. And therefore bending moment is 0. After this, we have bending moment maximum. So this is 1 and we have 2 meters. So we will have 1 into 2. So when unit load is at C, we are going to get this value as 2. And then we have this will be 0. So this is bending moment at D. Now this is also wrong. So this is also wrong. So this is also wrong. So automatically this is correct because ILD for shear force at C they are interested. So we have here. So when unit load is between, so C actually we are going to be likewise. Now when unit load is between A to C, we have shear force is RB which is 0. And when unit load is C to B, we have 1 minus RB. So 1 minus 0, we have 1. And then 1 minus 1, 0. So we will have this will be ILD for shear force at C. And then we have correct option that is D. So this value is 1. So this is 1. So likewise we have to see all this. Now the maximum bending moment at D of the beam shown in figure question 5 due to moving load more than the span. Now we have plotted ILD for bending moment at D and then we got this. So this is D. We have this as A. This is 4 meter. So we have here C. This is 2 meter. This is 2 meter. Here we have B. And if we will see ILD for bending moment we got. So we got this value will be in this fashion. And we have value is 2 over here. And therefore we will get maximum bending moment UDL greater than this span. Therefore we have that is equal to 1/2 into 2 into 4 which will be area. So 1/2 base 4 height 2 and we have 20. And from this we will get value of maximum bending moment as 80 kilonewton meter. And we have option that is B. So for 6th we have option is B option. Then we will go to question 7. A wheel of 20 kilonewton is moving. What is the maximum shear force at a point E which is 3 meters? So we have here 3 meters. And we are interested to plot. We are interested to find maximum shear force. Now if I will draw the diagram of this, then we have this will be 2 meters. Then we have this will be 2 meters. Then we have somewhere it is 3 meters. This is 2 meters. Now if we will go to this, and if we will plot reaction over here, or if we will say this will go down, this will go up, or if we will plot reactions, then we have reaction. This is A, R A, I can say. This we have, sorry, R D we have, and this we have RC. So if we will plot ILD, so I will draw it by dotted line. I will change the color, and then we can have this as. So we have 1 at this, and definitely we should have 0 at C. So this is for RC. So this is 1. And then we have, sorry, this is 1 at D, and therefore it will be 7 by 5, and this will be 2 by 5. This is ILD for RD. ILD for RD. Now if we will plot ILD for RC, and now I will plot this ILD for RC, that is minus, because shear force at C we have minus RC, and therefore we will have 1 at C, and then we have 0 at D, and then we have minus RC, so it will be in this fashion. We have this value. This is 2 by 5. This is 1, and we have this as 7 by 5. Now, when unit load is between A to, if I will mention it as C, then we have now RC. Now I have plotted on negative side, so we have to consider this portion till E. Now this is 3 meter, so we will get it as 3 by 5. And when unit load is between E to B, I have this red, that is RD, and therefore we will go this red portion, which is RD. So this portion I can say. And this is 2 by 5. So if we will plot this diagram, then we will get this diagram as this will be 2 by 5. Then we have at D it is 0. Then at E we have 3 by 5. And if we will plot it, then we will are in this fashion. So this is 3 by 5. Now then we have, so I will better change the ink, and that will be better. So whichever portion we have considered, I will plot that portion by that color. And so it becomes easy to you to understand the things. So now I will plot blue between A to E. So A to E we have blue. So this is 2 by 5, and we have at E it is 3 by 5. Then at D we have this value is 0, and then we will plot this. So this is 2 by 5. This is 3 by 5. And then we have, for remaining portion, we have this line, that is red line. Then I will plot this red line. So I have this as 2 by 5. And again, we have at C it is 0. And here again, we have 2 by 5. Now we have 20 kilonewton load is moving on the following left to right. So where we have maximum ordinate, so we have this will be minus 3 by 5, this value. And then what will be maximum shear force? Because they have not asked positive or negative. So we will consider maximum ordinate, we have 3 by 5. So 20 into 3 by 5, and that comes 12 kilonewton. And then we have this will be option D. So we have option D. So this is problem number 7. Now we will go to problem number 8, and that is again related to question 7. So we have to find maximum hogging bending moment at E. Now I will draw that diagram again. So we have this as D. Then we have E, that is at 3 meter. Then we have C, which is at 2 meter. This is 2 meter and again 2 meter. Now if we will draw bending moment diagram, then we will get maximum value at E, and we have that value, that is AB by L. Now A we have 3 meters, B we have 2 meters upon L, and it comes 1.2. Now we have to extend these values for your cantilever portion, and that I will extend it. So we have, this will be extension of this. Same we have on this side. So now on this side, again it becomes 1.2. Then this side I have. Now here we have actually 3 meters. So similar triangles we will have. If I will say y, then we have y by 2 is equal to 1.2 by 3. Now we have to use this. And from this we will get y is equal to 0.8 meters. So we have y, that is 0.8 meters. Now we have 100 kilonewton follows 20 kilonewton. And it is from left to right. So we will have now choices. If I will put 100 kilonewton over here, because hogging we require, and hogging we have these two. And then we have 100, and then another at 1 meter, so it will be 0.4. So this is 20. And then we will get maximum hogging bending moment. And that is equal to 100 into 0.8 plus 20 into 0.4, and it comes 88. Here unit we should have kilonewton meter when we will talk about bending moment. Now if we will put over here, then we have here 20, and then here we have 100, because we have 100 follows 20, and this is 0.4. And then from, sorry, this is 1.2, this is 0.6. And so if we will consider this one, then we have 100 into 0.6 plus 20 into 1.2, and we will get it as 60 plus 24, 84 kilonewton meter. So we have larger value, that is 88 kilonewton meter hogging. So we have option, that is B, and it should be kilonewton meter. So now we will stop here only today. For this, now we will go with third video for 9th and 10th. So thank you.